Hey students, Mr. Helpern here. In this video, we're going to talk about just the beginning of stoichiometry, the overview really of the steps that you need to take in order to solve problems. So we have drawn, very similar versions of this diagram. And if you haven't seen this, or if you have seen it but need a refresher, this is the short video that you might want to watch. If you know this already, maybe you can move on to the next one. So for solving these types of problems where we have two different substances that we're going to be using, either given an unknown, um, we have a reaction that we use. And that's something fundamentally different than the other mole type problems that we've been working with. When you have a reaction and an equation in front of you, you can use that, particularly the coefficients. They'll tell you the ratio of this reactant to this product, saying if I have, three wheels and one frame, I'll have one tricycle, right? So if I have six wheels and two frames, I'll have two tricycles, right? So it creates a ratio for us that's really helpful. That's the most new step that we've been adding, and that's really at the center of this diagram here, right here. Right, when we need to go from moles of something that's given to us to moles that's unknown, we write a mole ratio from the balanced equation, and we write it like this. We write moles of what we want to know, or the unknown, over moles of what's given to us. All right, and then we're essentially we solve that uh, step, and we get the moles of the unknown. And from there, we can either decide to stop if we're looking for just moles of the unknown, or we could go to the molar mass of the unknown, the volume of the unknown, or the molecules or atoms of the unknown. Right? So this is a helpful tool. Some students sort of practice it enough that they remember this without really needing to, memorize it or keep coming back to it. But some folks like to memorize it and just write it out as a tool so that they can use it when they're solving these types of problems. So let's just practice this a couple of times. So this is an example here. In this reaction, we have boron and hydrogen, right? And we also have oxygen gas, and this is a type of acid, boronic acid, and then you have water. So the first step is taking a look at this reaction and making sure that it is perfectly correct. In other words, that you have products and reactants that first have the correct number of elements on both sides, and the correct number of atoms of each element particularly. So let's look. We have two borons here on the left and only one on the right. So the first step I'm going to try is just putting a 2 in front, just to see if that helps. Now, I'm looking and I see that I have only two oxygens here and only one over here. So I'm going to make this a 2 as well. So now I have, sorry, sorry, I had, let me backtrack for a second. It's okay to make mistakes, right? And this is definitely a mistake I just made. There's two oxygens here, but now I have 4 from putting a 2 in front, and I have another one, a fifth one, from the water. So that can't, it doesn't balance out. So what if I look at my hydrogens and I say, if I have 2 of these, right, my hydrogens would go from, you know, to 4 now to 6. Ah, that matches the hydrogens. 6 over here. And now I have 4, 6 oxygens, right? And so I should balance it on this side. So that's a 3 here. 3 times 2 is 6. And now I'm ready to go. My coefficients are 1, 3, 2, 2. Now, why is that important again? Well, again, when we have this middle step where we're using our mole ratio, we're going to use those coefficients to create a ratio to jump from the moles of one known substance or given substance to the moles of the unknown. Okay, so this is the example here. What mass of O2, okay, so that's my unknown, O2, and will be needed to burn 36.1 grams of boron, boron with hydrogens. So now, this is my given, or my known. So I'm going to start with what's given to me. I'm going to write that down first. That's my first step. Okay, now, if I go back here for a sec, I am here with my mass of my given. What I have to do is finally figure out what is the mass of my unknown, in this case the mass of the oxygen. So this is my roadmap. I'm going to go from my mass of my given to my moles of given, my moles of given over to the moles of known, and finally the moles unknown to the mass unknown. So there are going to be three fractions here, three steps to this. The first step is going from mass to moles, so I'm going to divide by my molar mass. So for every 1 mole of B2H6, I'm going to have a certain number of grams. Now, I want to show you how we do this. We go to the periodic table. We look for boron. Boron is 10.8 and hydrogen is 1. So we 10.8 times 2 is 21.6, right? Plus 6 hydrogens, that's 6 there. So that means that we have 27.6 grams of B2H6 for every 1 mole. Okay, now we have the moles of B2H6, but I want to get rid of that. Okay, now I want to put that again on the bottom this time so I can get rid of it. See, a lot of students kind of get confused about what goes in the bottom and the top in this middle step with the mole ratios. I like to just know that if I'm writing it out and I can cross it out, that's a good thing, right? But always we put what we are given on the bottom and what we want to know or what is unknown on the top. In this case, my unknown is my mass of oxygen, so I need to first go to moles of my unknown, my oxygen. Right? Now, I wrote this out here without even thinking, but I want to look, right? There's a 1 here, but the numbers here should match the coefficients, so this should be a 3. And last but not least, I'm now in moles, and I want to go to grams, so I have to multiply by molar mass. Oops. And for every 1 mole, again, I want to cross out my units, right? So to cross out my moles of oxygen, I have to have moles of oxygen on the bottom. Now I can cross these out. And for every 1 mole of oxygen gas, I have 32 grams. And I get 36.1 divided by 27.6 times 3 times 32. And I get 125.6 grams of O2 gas. Okay, so that's how we solve that problem. We're going to do one more before we head out here. We're going to figure out the moles of water. So in this case, water is my unknown. That's produced from 19.2 grams of B2H6. So here we go. We have 19.2 grams of B2H6. We always write what's given to us. And we want to double check, right? We're going from grams of what's given, and where do I want to end up? Well, I don't want to end up where my mass, I actually want to just end up with my moles of water. So I just need to go from mass to moles, and then moles to moles. So I'm going to go from my mass to my moles. So I go and divide by the molar mass. In this case, again, it's 27.6 grams of B2H6 for every 1 mole of B2H6. And then I'm going to do my molar ratio. I'm going to take my moles of B2H6 and I'm going to put it on the bottom because that's what's given to me. And what's unknown goes on top, which is my water in this case. Now I look up to my balancing reaction. I notice that water has a 2 in front. For every 2 moles of water produced, I need 1 mole of B2H6. There's no 1 in front there, but if there isn't anything written, we assume there's an invisible 1 that's there. And last but not least, just kidding, last but not least, we are done. We just have to solve because guess what? We just ended our last step in moles of water, which is exactly what we want to end with. And so I solve 19.2 divided by 27.6. And then we multiply by 2. And I get 1.39, call it 1.4 moles of water. All right. Hopefully that was helpful, just going through a couple of problems. In the next video, we'll talk a little bit more about problems where you have a formula and then problems where you don't and what you need to do there. And then the final video would be on limiting reactants and how much excess you have. See ya.